In this video, we'll study about the circle theorems. So the circle theorems are the rules or principles which are applied when some angles are formed within or outside the circle. So we'll study those first, the parts of the circle, a quick review of the parts. So this is the diameter here, and as you can see here, the diameter starts from one end of the circle and to the other end of the circle, passing through the center point. And radius is from the center to the circumference, and it's equal all around the circle. And this is the center, and this is a sector. So a sector is a line which is crossing a circle from anywhere, and the chord has to start at one end and end at the other end of the circle. Means it should touch 2 points in the circumference. So if this is a circumference all around, so it should touch two parts and divide the circle into different portions. So this is a segment, and it's a minor segment. It's called minor segment because the chord divides a circle into one or more segments. So this is a minor segment, and this side is a major segment which the chord is dividing. And tangent is a line which is just touching the circumference of a circle. It does not cross inside, it just touches the side. So the useful definitions about the circles is perpendicular, that means it has a 90-degree angle; bisector, that means it divides into two equal parts; and subtended angle. So subtended angle is the angle formed by an arc. So for example, if this is an arc and this angle is subtended by this arc, because the two sides of this angle, the endpoints are located at the endpoints of this arc. So this type of angle is called subtended by an arc. And the next definition is semicircle. So the semicircle is kind of half a circle. So coming over to the theorems, theorems are rules which are applied to the circle. So the first rule is alternate segment angles and the tangent to a circle are equal. So if this is a tangent which is just touching a triangle, so the angle here will be equal to this angle in the alternate segment. So this one is the one segment which this chord is making. So the angle, alternate angle in here, so it is in the other segment, that will be equal to the angle which this tangent line is making uh, with this here, when the triangle vertex is touching to the surface or the circumference here. So this is a first rule or the theorem of circle. And the second theorem is a tangent and a radius meet at 90. So for example, there is a tangent line passing through. The tangent is the line which just touches the circumference and passes through it, and a line from coming from the center or the radius is always 90-degree angle. It does not matter, it can be on this way as well. So even if it's here, it will again be 90 or anywhere. So a tangent and a radius meet at a 90-degree angle. So this is also a theorem. And two radii form an isosceles triangle. So whenever there is a radius and two lines coming out from the radius and touching the circumference of a circle, and they always make an isosceles triangle. So if it's an isosceles triangle, that means that these two sides are equal, and the angles formed by these two sides are also equal. So these two angles are also equal. So a radius making two lines it the circumference. So the angle triangle made by these two lines will always be isosceles. So this is another theorem. And the next theorem is the angles at the center of a circle is twice the angle at the circumference, right? So if there is an arc, right? So this arc is making an angle here at the center 20 degrees. So if the same arc subtended by the same arc, another angle is being made here, theta. So this theta will always be half of the angle which is at the center. If this is a 20, so this theta will be 10. So it does not matter that it is not necessary that this angle should be right, in front of across this 20. It can be anywhere, right? It can be anywhere on this circumference, but the condition is that both the ends should touch at the same arc. So this angle can also be 20, or even it can be here. This can also be angle can be 10. So the another theorem which we'll study later. So if an angle which is subtended by the arc, in the opposite segment, they all are equal. Now here, this angle, this angle, this angle, all these angles are supposed to be equal, and they all will be half of the angle at the center. And the next theorem is angles in a semicircle are 90 degrees. So whenever there is a semicircle formed by a diameter here, this is a diameter. So an angle which is formed by the two ends of the diameter at anywhere on the circumference will always be a 90 degree. Right? So it doesn't matter if it goes there and then comes to this end. If it's A and B are the endpoints of the diameter on the circumference, so any angle that touches from these 2 points, originates from these 2 points, and touches at the circumference will always be 90-degree angle. So it can be like this, again 90-degree, or it can be like this, again 90-degree angle. So all these angles are 90-degree angle. And so this was the angle which I was discussing above. So angles in the same segments are equal. So if there is a chord, right, and this chord is making this here is a chord, and this chord is making two segments. This is minor segment, and this above one is major segment. So it's making an angles. So you can see here, one angle is here and one angle is here. So the angles in the same segment are equal, which are made by the chord at this place. So the angle originating from the endpoints of this chord, of this arc, endpoints of this arc, and in the same segment are always equal. And the next theorem is opposite angles in a cyclical quadrilateral add up to 180. So in this circle, we have got a quadrilateral. So a quadrilateral is a straight line shaped which has four sides. So a four sides shape within a circle which the vertices of this quadrilateral are touching the circumference. So in this case, the opposite angles are equal to 180. So A and C here will be equal to 180, and D and B will be equal to 180, and all the angles in a quadrilateral are equal to 360. We know that if we a plus b plus c plus d, so all these angles always equal to 360, and angles in a triangle always equal to 180. So the interior angles of a quadrilateral equal to 360, and interior angles of a triangle 8 to 180. This is our previous knowledge, but this theorem says that the opposite angles in a cyclical quadrilateral, that means that this quadrilateral has to be covered by a circle where all the vertices of quadrilateral should be touching the circle. So in this case, so opposite angles add up to 180. So the next one is the tangents from the same points are the same lengths. So if there is a tangent, two tangents, and they originate from the same point and they touch the circle, so these two will be same. So these two tangent lines will have the same length. Some questions in which we can apply the circle theorems. And the first question is here, from questions 1 to 10, colored angles, explain your reason. So what is the colored angle here? So we can just look here. If this one is 160, so the opposite side, this one should be 200 and 200, because angles all 360, so this 160 minus 360 gives us 200. So if this is 200, is we know that the angles making at the center and these two angles making at the circumference is half. So if this is 200, this should be 100, because the angle at the center is double the angle at the circumference if there is a chord. So this is a rule, and the same rule applies here as well. So if this angle is 300, so that means that this one angle is 60, because the angles all in a circle are 360, and if this angle is 60, that means this angle should be half of it, so it should be 30. We go to the question number 3, and in question number 3 we can see here, we have got this angle is 210. So if this angle is 210, so the angle which here is a chord, and this chord is making an angle 210 here. So if this angle is 210, we should find this angle. So we should 360 minus 210, and it should give us 150. This angle should give us 150, and the angle it here, so this angle is 45 here. So the reason is that the angles in a quadrilateral always add up to 360. So here we have got 80 here. So if this one is 80, so here this angle should be 40, because we know that the angle formed by an arc at the center is double than what it makes at the circumference. So if this is 40, that makes this line, and this line, all three are radius, so these all three lines are equal. So if these two lines are equal, we also know from the previous that the two of the uh, radius, they form an isosceles triangle. So if this is isosceles and this one is 30, that means this one should also be 30. So if this one is 30, so then the opposite side it should be 10. And if this is a 10, it should also be, so this one should be 10 should be our answer. And in question number 5, we are asked that what should be this angle here. So we can see from here that the angle, this one is 140, and the angles on a straight line always add up to 180. So what we do is 180 minus 140, and this one is 40. So if this one is 40, that means that the angle at the center, this one should be double of 40. That means this should be 80. And this, if this angle is 80, so this whole should be 360 minus 80. The angles in a circle are 360. So what we do is we simply 360 minus 80. So this should give us 280. So this angle will be 280. We can see here that there is a small chord which is cutting this line, but at the same time we can see that this angle, the line at this here, it's a 70. And what we can do is we can just go like this one is an arc, so the angle formed by this arc at the center should be double than this angle, right? So if this angle is 70, so angles in a straight line always equal to 180. So we apply the same procedure, and 180 minus 70 gives us 110. So this angle is 110, and the angle here should be double. That means this angle should be 220. So if this angle is 220, then the angle which has been asked should be minus 360. 210, 220 minus 360. It should give us 140. 140 should be the answer. Here is 90. That means the angle, opposite angles when the two lines cross are always equal. So that means this angle is also 90. So if this angle is 90, this is 30. So angles in a triangle add up to 180. So 90, 100, 10, 20. So these two angles make up 120, and the total are 180. So this gives us 60. So this angle is 60. So if this angle is 60, that means these two angles are equal. So this angle is also 60, because the theorem says that the angles subtended by an arc are always equal, are always the same, are always the same. So if this is 70, that means this one will always be 70. And if this one is 70, so if we can see that here, so if this is 70, then on a straight line it will be 180. So this angle we can find by subtracting this 70 from 180, and that will be 110. So this angle will be 110, which we need to know. And in question number 9, we have been given these two angles. So if we take this as an arc, this as an arc, and the angles subtended by this arc are these ones. One is this angle and the second one is this angle. So if this angle is 40, then that means this angle is also 40, because these two angles are subtended by this arc. These two angles are 40. And then if we take, what we have to do is, two opposite angles are always 180. So this one is 80. Now this one is 40. We are only left by this one. So what we do is 180 minus 80 plus 40. So this is how we can solve the question. 180 minus 80 is equal to 100, and minus 40, this gives us 60. So this angle is in fact 60. In question number, this is an arc, subtended arc, and the angles formed by this subtended arc, this is 24, and this should always be 24. So if this angle is 24 here, okay, so that means 44 plus 24, and plus this angle should always be equal to 180 minus 24 plus 44 should give us the required angle, and that will be 180 minus 24 minus the 44. This gives us 100, and given us these two, this 35 and this x, we have to find what is the x. So whenever there is a center and a radius passing from the center to 2 points, so we already know that these two lines are forming an isosceles triangle. So when there is an isosceles triangle and one side is 35, so that means this side is also 35 degrees. So if these two sides are 35, and then the inside of a circle is always here, by subtracting it from 180 minus 35 minus 35, and it gives us 110. This one is 110. So the angles on a straight line are always equal to 180. So if this one is 70, 90, because an angle formed by a tangent and the radius is 90. So now this angle, it's pretty easy and simple. So what we do is from 180 we subtract 90. We are left with 90, and then we again subtract 70. So we are left with 20. So 20 is our required angle. In question number 12, this diagram and this one is also 90. So now it's a quadrilateral, and we have got 90, 112 and 90, and we are left with the last angle, which is G, that should be subtracted from 360. So 360 minus 180 gives us 180, and minus 112 further gives us 68. So this angle is 68. The second angle is also 41, because the angles in forming by the radius, the two lines are equal and the angles are equal. So these two angles are 45. Find the angle of this one. So it's like total 180. So what we can do is 180 minus 41 and 41 is 82. This gives us 98. So this angle is 98, and if this angle is 98, then the angles on a straight line again sum up to 180 minus 98, so this gives us 82. This one gives us, this angle is 82, and if this angle is 90 here, this whole angle is 90, so we can subtract, because in a radius, in a semicircle, the angles are 90. So if the angles are 90 and this angle is 41, so again we can subtract this 90 minus 41, and this gives us 49. So now if this angle is 49, we found this angle is 82, so we can find this angle as well. So we have to just 180 minus 49, and then again we minus it with 82, and this gives us 49. So you see, if one angle is known, we can find all the angles in this semicircle. Question number 14, it says work out the size of angle ABC, give the reasons. So we have to find here the angle ABC. So if this angle is 87, that means the opposite angle in a quadrilateral in a circle are equal to 180. So we subtract this 87 from 180. That gives us our answer of the angle C is 80, 93. It's 93. And then if this angle is 108, so that means this angle should be sum up to 180. So what we do is 180 minus 108, and this gives us 72. It should be equal to 180. So 180 minus 72, this gives us 108. So the B should be 108. So the reason is same, because 108 plus 72, that makes up B plus A is equal to 180, and this C and 87. 87 plus C, it should again give to 180.